Welcome back to my channel. Always a new project going on. So the new project is I installed this curved cylinder, but actually it doesn't work. It actuates, but actually I won't be able to dip the bucket. It will be always full. So what I did is I changed the cylinder. I changed for a 16-inch stroke as it was before, but it's not the same kind of cylinder. I show you the old cylinder. So that's the old one. If it seems to be a little bit bent, it's bent. And if this fork seems to be bent, yes, it is. So this cylinder compared to this one, it's actually the same stroke, but the length in between the two pins is not the same. There's like 1 or 2 inches less on the other, and you can see why. At the end of the cylinder there's still a fork on this side. On the other one, this rather bushing about being well at the bottom of the cylinder. So I'm gaining maybe 1 or 2 inches, which is good because before I was not able to curl up with material in it when it was at the lower position. So to say, I could straight on the ground, but I could not tilt up. So now I can tilt up, but it's limited in action and I could not pour the content of the bucket. So that's a good problem because actually this cylinder was 2 inches in diameter, and I managed to get a new cylinder 2.5. Okay, that's the old cylinder compared to the new one. It's fully retracted. I got 26.5. So this one I get exactly 16 inches. Okay, 16. And from pin to pin, center of the pin to the center of the pin. I get exactly 40 minus 16, 24. So I have 2.5 inches less. So that means I can curl up really more, but I cannot dip that much. So this cylinder is a 2.5. This one is 2 inches diameter. Doesn't seem that much a difference. So the force of a cylinder is proportional to the area of a cut section of this cylinder, and you multiply that surface by the pressure, pound per square inches. So I'm looking for the square inches of that cylinder compared to this one, As you remember, with the gauge installed, I had 1300 psi. It could be a little bit higher than that because it was what I reached at the idle speed. So calculating the surface of this one, so 1 multiplied by 1 multiplied by 3.14, which means 3.14 square inch. This one is 2.5 divided by 2, 1.25, 1.25 by 1.25 by 3.14, which is 4.90. Okay? If I want to compare to this one, how much force I get more, oh, I missed. Okay, 4.9 square inches, and this one is 3.14. So I get 56% more force with this one, which also means it's 56% slower. So I'm not going to keep the same distance in between the pivot point and this attaching point. So basically I could cut it by maybe 56% or something like that, or maybe, let's say I have 10 inches, I could go down to 6 inches and still I would have the same curl power on it, and yet the same speed I had before. So what I would get is more span in between the dip and the curl up. So that's what I will be doing. I'm going to remove or maybe keep those attached point, but move it a little bit below. I have to make sure that the bucket will not, this part here will not hit the cylinder there. So that's why I'm going to use the crane to make some simulation of the new pivot point or the pin point. So let's see that. Okay, I'm going to raise and lower the bucket, and I'm going maybe to do it by hand. I don't know how heavy it is. One thing, I want to make sure that it's not going to come loose. So I'm going to use as much as possible closed system, not just open, so it doesn't get loose. Okay. Okay. I get roughly 45 degrees between this edge and the bottom of the bucket. So I have to reach at least 90 degrees with this one, if not more. So I'm going to reach a little bit more than that. So I'm going to free the pin, and we'll see where it goes. Okay, based on that, maybe okay, at this point you can see that it's going fast. Each quarter of an inch makes a lot of difference. Okay, that's exactly in the same line. So what do I get there? So I get 2.5. That's a good point because I'm going, so at this point I get the same capacity to empty the bucket when the bucket is reached. So when the bucket is lower, then you get some angle, but as much as you get high, the angle is really limited. I'm also going to look if I can maybe improve a little bit more. Okay, like this. So one really important point is that this center line of working for this cylinder doesn't reach below this point. If it does, and I have some implement that does this, then you get stuck on the other side. So when you curl up, then it's going on the other side. Really bad, and it can bend a cylinder. Believe me, it can happen. Okay, so at this point, that's the lowest point, and I go just a little bit more. That's exactly what I don't want to happen. Okay, that's no good. Okay, that represents the center of the pivot point. Actually, not really lower than that. Maybe like this is the maximum I could expect to have. 3.5 compared to 2.5. So I gain some movement. So currently the bottom of the bucket is about 10 degrees from the vertical point, like this, which seems to be satisfactory for me. At a move of the pin of 3.5, I'm going to go back to 2.5 like it was before. I'm not yet there. Now I am 2.5. I'm going to see what the angle is. So that's the bottom of the bucket. So I'm 30 degrees. So I gained 20 degrees, which is huge, which seems to be satisfactory. But is that too much? Maybe, because I'm really seldom dumping at so much high. I finally found the what I think could be the perfect configuration. The previous hole was about there, and this one is about 3 inches closer to the other. I feel that I could get all the movement I need and yet enough strength to lift the bucket. So I did put it level to the back of the bucket. I did confirm the distance from here to here, so I could be okay like this, and I confirmed the distance in between, and referencing to the old brackets, it seems also perfectly in center. So I'm going to put some not only small tacks, because it's going to pull kind of hard anyways, even if it is only an empty bucket. So as you may notice, I make sure that the tractor is not connected to the bucket. Once in the past, I had some issue with the alternator, getting some current from the welding process and breaking some diodes. Oh, that's a good idea. Nice. Okay. I've been asked by FP from Holland, what about welding on the paint, because you can see me welding on the paint most of the time, let's say so. Actually, I'm not welding on the paint. I just clean enough surface that I get good contact to start, and after that sometime I weld over the paint. It's not either, it's not the real way to do. On this one, because it has to hold a tremendous amount of weight, I did grind this down to the bare metal. And same about this this metal, because there's some black coating on it, the scale, or I don't know what the name is. So I did prepare this really well, so I get the best weld possible. So I'm going to clean the first weld I did, because there's flux, and then I will be ready to make the full weld. So this is an open hook. This is a closed grab hook on one side, the other side, and this is one closed loop. So whatever you need to grab. So this one is for hanging chain behind the bucket, and this one is to hook chain on the front, from the front of the bucket. Closed loop, whenever you need to make sure that it won't go off, and the open loop, especially for the slings or something like that. So I'm really happy with that setup. I'm always having whatever I need with those hooks. Like a pro.